Let's add now our message server logic that will allow us to perform state transitions. So inside the keeper directory, we're going to create a file called message server.go. This is going to be within the package keeper, and we're going to have a type message server that's going to be private. That is going to have the keeper is just the keeper route, and this message server has to comply with the corresponding SDK types message server. That one, yeah, it has to comply with our message server defined in our generated protobuf. You see that we have this message interface, and it's a create game, make move, and update params, and this should be the interface that complies this message server. And we will need also a function to instantiate this, a new message server implementation that would take a keeper as input parameter and it's going to return our message server interface, that in our case is going to be this private message server using the keeper that we are providing here. Now this private type message server has to implement a create game function with this signature that's defined in this interface. These are the methods that we have to define. This is in types. There you go. For now, let's just return nil and nil to remove these different warnings, linter warnings, compiler warnings. Let's add all the ones that we need, the make move and the update params. Let's add just this to have it here. Make move and update params. Update params. And we take these imports to bring these types from the types package. Now we're compliant with the interface. For now, we're just going to add the create game logic. It is quite straightforward, so we're going to have a new game that's going to be created from the message. So we're going to have our game number. If you remember, we defined next game number function from the keeper, so we can get the next game number. For that, in the context, passing just the context that we have to define here, the message. Then our player A is going to be the message creator. Remember, this message, we define it in our proto as well, and we have these three fields: the creator, the opponent, and the rounds. So the opponent, player B, is going to be the opponent. The rounds are the ones that the message is sending, and the status is going to be a status waiting. Status is defined in our rules, so that's the initial status. Next, we're going to validate. We're going to use the validation function that we defined previously. So let's validate our new game to make sure all the fields are compliant with the rules that we defined. If there's an error, we'll return this error. And after everything is valid, we can just save this to our state, and we will be having a new game in our store. So we can use the keeper games set, and we will set this to be with the key game number and the new game as the value. If there's an error, this will be reverted, and we're going to return this error, new error. If everything goes fine, we're going to return just an empty message create game to signal that everything went fine. The next step is to register this message in our application, and that is done in the codec. So if you remember, we had this register interfaces function where we have to add here our message. In this case, we're going to add the message create game, and we're going to add this import for the types, Cosmos SDK types. Well, I just call it SDK. And this register interfaces is called in the module that is registering everything, and we have to register here our message server. Now it's working because we have this function that we just implemented to register the message server. This will leave it commented out for now. CLI commands. So we'll have to make some changes in the auto CLI. So let's go to auto CLI file, and now in here we're going to add a transaction, and we need this service command descriptor. The service is going to be our RPS v1. RPS v1, there we go. And this is a message service descriptor. Service descriptor, service name, and the RPC command options will have this to be a type, RPC command options. And here the options that we have at the moment are the RPC method that's called create game. We can find the use. The use is how you use it. Opponent. To create a game, you will need to pass the opponent and the rounds, because the creator of the game is going to be the signer of the message, so we only need to define the opponent and the rounds. Remember that our message for creating a game is just the creator, that's the signer, and then we have opponent and rounds, so only use create and pass the opponent and rounds. Let's close this for now. Short description creates a new rock, paper, and scissors game for the message sender and the chosen opponent. And then there's a long description that you can use as well. Here we'll add in some more information. Input parameters are the opponent address and the rounds number for the game. And then we have some to find the positional arguments, and this is going to be a slice of positional descriptor. This is just defining what are the fields So the first one is going to be the opponent. The second one is going to be the rounds. Let's format this. And now we should have everything set up to wire our module with the corresponding CLI command. Let's try to install this. If everything is fine, should compile. It's compiling. Now we can do a make init to initialize our node. Everything went smoothly. You see we have the RPS here with the default games that's empty. And we can check if the command was wired properly by checking the transaction and see if we have listed here the RPS. Yes, you see we have RPS command for the RPS module. That's our custom module. If we do RPS help, let's see if we have our command. Yes, you see we have, oh, actually it's automatically picking up the make and the update params. But the one we have defined for now is just this create command. The other ones are not wired up, so they will not work. But let's start to create a rock, paper, and scissors game. So for this we'll need two consoles. We're going to start the node on one console. This is our chain starting. And in another window, we're going to perform this transaction. So let's see, we will need a couple of addresses so we can list the keys that we have. We are going to make Alice to create the game using Bob as an opponent. So let's see how that turns out. We're going to do rock, paper, and scissors transaction RPS create is a transaction where we'll have to define our opponent, which is Bob, and define the number of rounds. And these transactions will going to be signed by Alice. Let's see if this goes through. We have to sign and broadcast the transaction, and there it went. We can check the status of this transaction to see if it was successful. And it seems that everything failed. Invalid score. Okay, yeah, we have to check the validation. As you see, this is one of the errors that we define, that we are having an invalid score. Let's check that logic. Again, here we have our score. Okay, yeah, when we initialize, we have to add at least this empty score to initialize it to be 0, 0, because by default it's going to be nil. This score, remember, it is a slice. So let's do that. Let's stop our chain for now. And let's go to our message server. Here we are filling the game number, the player A, player B, the status, the rounds. These moves are okay to be empty, but the score should be 0, 0. So let's validate this. Let's add this to be int 0, 0. So score is initialized to be draw at 0. Let's install again. And now we can start the chain again. Let's try to submit the transaction once more and check for if there are any errors. Broadcast. Let's query this hash. What happened with this transaction? Let's see. Now code 0 is okay, so we don't have any errors now. The game should be created. At the moment we don't have any way to query the game, but if you remember correctly, we can export the current state of the chain to see if that was stored properly. So we can stop the chain now. and run the rpsd export command, and we're going to dump this to a temporary genesis.json, and let's open this temp file to see if we have the game stored properly. And we're going to format. If we look for RPS, should be down here. Yeah, as you can see, we have stored correctly our game, so our logic is good so far to create a game. Now let's continue adding the other transactions. Now that we learned how to implement our messages, go ahead and implement the make move logic. Here I added the make move logic. Make sure that you make all the valid checks before persisting the changes on state. I'm doing some valid check for the move to see if this is a valid move, the one that's sent in the message. Also checking if the game exists, that the game status is in progress or waiting, otherwise we will not be able to play this game if it has ended. And also checking that the player is in the game and that it can perform the move, in the sense that it is the player's turn to move. And then checking if a round ended, determine the winner of this round, and then get the next status of the game. If there's a change, if somebody won, or if it is still ongoing. See here, it's going to check if the player A wins or player B wins, or it is a draw, or it's still in progress. So we'll update here the status, and then we validate that everything is alright, and we set the changes to our state. After this, you have to make sure that you have registered the corresponding interface for the message and also the CLI command. So let's test if everything went okay. Let's try to make a player to make a move in our game that we just created. To do that, we will have to install again the binary to pick up the latest changes. Make install. This will compile again the application to get the new message that we added. Let's check if everything's okay. We're checking the version. We're good, and we now should start the node from the current state. Make sure that you don't run here the making it, because the making it command will reset our database. It will start from scratch, and we don't want that. We want to keep with the game that we created previously, so we can use that one to test the make move. So we're starting our chain, and let's open another terminal to submit a make move. So for this game that we already created, it's the game number 1, and Alice and Bob are playing. So let's make a move with Alice. We can do the rpsd transaction rps, sorry, and let's see which are the available transactions. We should have here our make move, and let's see, make move. Let's get the help and see what's the required values. That should be the ones that we set, the game index and the move. So we're going to do a move in game 1, and we're going to choose rock, and this is going to be Alice. Let's broadcast the transaction, and we can query the transaction received to see if this was a successful transaction. Let's check the status.
seems to be okay. Code 0 is okay. And the message is the one that we want to send. So now let's check if we export the state. If we have a move on players A move, we can export again the state into a temporary file that we're going to call genesis.json. And let's open it in our IDE, Genesis, and let's check it out. If it is recording the move properly, we'll look for the games. As you can see, we have this game number 1, and player A submitted a move that it's rock. So it worked correctly. The score still is not updated because player move still has to make its move. But that worked perfectly. Now let's look into the queries so we don't have to export the Genesis to check what's the current state of the chain every time we perform a state transition.